What if I told you that, while Western countries debate for decades about building a simple bridge, China rotated a 16,000-ton bridge and connected it in just 90 minutes? And they also built the world's longest sea-crossing bridge with millimeter precision in conditions many U.S. engineers deemed impossible. Today, we're diving deep into 20 of China's most mind-blowing infrastructure projects that have left engineers around the world absolutely speechless. In 2015, Beijing's Sanan Bridge, used by over 200,000 vehicles daily, began to sag dangerously. Most countries would take months or years to replace it, but Chinese engineers did it in just 43 hours. At midnight on November 13th, crews began cutting the old bridge into 27 large sections, the biggest weighing 139 tons. Blasting was avoided to protect the supports, and cranes carefully removed each piece. Nearby, a new 1,300-ton bridge was fully assembled and ready. Two massive Shen 20 transporters, each with 96 wheels, moved it with synchronized precision. Using GPS and lasers, engineers aligned the new span to the millimeter. After final checks, traffic resumed in less than 2 days. This project showed China's ability to solve complex problems quickly and accurately, combining speed, precision, and confidence unmatched by most other nations. Can you imagine replacing a major city bridge in just 43 hours where you live? How long do you think it would take in your country? If replacing a bridge in 43 hours was impressive, China went further by upgrading a major high-speed rail station in just 9 hours. Longyan Station in Fujian needed to connect to a new line to cut travel time from 7 hours to 90 minutes, using bullet trains running at 200 kilometers per hour. But extended closure wasn't an option. Success came from months of planning and the use of prefabricated parts. Tracks, sleepers, and ballast were built off-site like giant Lego pieces for fast assembly. When work began, 1,500 workers were deployed with clear tasks. Some removed old tracks and switches, while others operated cranes and machines to position the new components. Prefabricated sections were set in place using laser-guided tools. Electricians rewired the system to ensure safe operation, and crews rebuilt the crushed rock foundation for a stable ride. By sunrise, the upgrade was done, new tracks installed, systems tested, and the station ready for high-speed service. This project shows China's mastery of prefabrication and logistics, achieving construction speeds few other nations can match. Don't miss the next engineering feat that we write. Subscribe and turn on the notification bell so you're first to know when we go live with the next mega project. The Kong-Zhuhai-Macao Bridge, the world's longest sea crossing at 55 kilometers, redefined modern bridge engineering. Built to connect 3 major cities across the Pearl River estuary, it overcame challenges like busy shipping lanes, strong typhoons, fragile ecosystems, and the habitat of the Chinese white dolphin. The main bridge spans nearly 30 kilometers with 3 sail-shaped cable-stayed sections. To avoid disturbing marine life and shipping routes, engineers built artificial islands that serve as ocean interchanges with extreme precision. A 6.7-kilometer underwater tunnel forms the project's core. Made from 33 concrete segments, each the size of an 8-story building and weighing 80,000 tons, the tunnel was placed on the seabed with only 5 centimeters of error. Engineers used a technique called composite foundation treatment, strengthening the seabed after 137 failed attempts. In May 2017, a tidal surge misaligned 2 tunnel pieces. Within 15 minutes, China's hydraulic adjustment system corrected the position with millimeter precision. The bridge is designed to last 120 years and can withstand magnitude 8 earthquakes, category 16 typhoons, and ship impacts up to 300,000 tons. Its strength is not claimed, it is tested and proven. While others debate smart cities, China built one, Huajiang, in just 7 years. This $95 billion project eases pressure on Beijing by serving as a second capital hub. Spanning over 2,000 square kilometers, it's a fully planned smart city built from scratch. Underground, Huajiang features a unified system where transport, utilities, water, power, and fifth-generation networks function as one. above ground, thinking roads. Use sensors and fifth-generation technology to monitor traffic in real time, adjust signals and clear paths for emergencies automatically. In one example, if a fire breaks out, the system instantly maps the fastest route, turns all traffic lights green for emergency vehicles, and reroutes traffic, ensuring rapid response. Over 3,000 smart buildings have already risen from farmland. Construction has been rapid. Unlike projects in the West, California's high-speed rail is still incomplete after 16 years. Xiong'an also leads in sustainability. Green spaces are core to its design. An advanced system predicts air pollution and adapts traffic to reduce its impact. What sets Xiong'an apart is its start-from-zero approach. Rather than retrofitting old cities, China built a future-ready one from the ground up. Imagine moving the entire flow of the Colorado River across mountains, under rivers, and through thousands of miles. That's what China did with the South to North Water Diversion Project, the most ambitious water transfer effort in history. Costing $120 billion and spanning over 14,000 kilometers, it's so vast it's visible from space. The goal: move water from the water-rich south to the dry north, where cities like Beijing and Tianjin were running out. Traditional solutions couldn't meet the scale of the crisis, so China built massive infrastructure. The central route alone crosses the Yellow River and the Taihang Mountains, a challenge few countries could overcome. Hundreds of pumping stations, the largest in the world, push water step by step from Yangzhou to the Yellow River. Rivers that had never naturally met. Some sections pass under the Yellow River in tunnels, others cross above the Huajiang River on aqueducts, the longest stretching 9 kilometers. Nearly 400,000 people were relocated to make room. Villages were flooded and communities displaced. The project required coordination across 8 provinces and multiple river basins. Now, over 10 billion cubic meters of water flow north each year, enough to fill the entire Yellow River, serving 170 million people in 44 cities. 9 years into operation, it's more than engineering. It's a vital lifeline for the world's most populous country. Building a railway is hard, but building one across glaciers, earthquake zones, and towering mountains is something else entirely. The Sichuan-Tibet Railway stretches nearly 2,000 kilometers from Chengdu to Lhasa, cutting through some of the toughest terrain on Earth. It crosses 14 active fault lines and climbs to over 4,000 meters above sea level, where oxygen is scarce and landslides, avalanches, and earthquakes are common. Some tunnels take over 5 years to build due to shifting geology and freezing temperatures that drop below -40 degrees Celsius. At over 5,000 meters, the railway crosses the Tangula Pass, one of the highest rail routes in the world. Trains are pressurized like airplanes, and passengers need oxygen to breathe. Specialized concrete and machinery were developed to function in freezing, low-oxygen conditions where regular tools fail. The journey that once took 36 hours by road will now take under 13 by rail, dramatically improving travel across the Tibetan Plateau. Construction crews work in rotating shifts due to dangerous altitude sickness. Progress is slow, but every kilometer is a victory over nature. Despite brutal weather and unstable ground, engineers push forward. They've invented new methods to build on permafrost and created machines for extreme altitudes. This railway is more than just infrastructure. It's proof of China's determination to connect even the most remote parts of the country, no matter the cost. Beijing Daxing International Airport, opened in 2019 and built for $17 billion, is more than just an airport. It's a city with runways. Its terminal, shaped like a giant starfish, was designed for efficiency, reducing walking distances and easing passenger flow. Built in just 5 years, Daxing handles up to 100 million passengers annually, more than the population of most countries. Unlike airports that take decades to finish, China turned empty farmland into a global hub in record time. Construction required advanced engineering to stabilize soft ground and integrate high-speed rail and subway lines directly into the terminal. The result is a seamless connection between air, rail, and road. Inside, the airport features facial recognition for boarding, AI-driven air traffic control, and automated baggage systems. Sustainability is key too. Solar panels, rainwater recycling, and high-tech air filtration help reduce environmental impact. Daxing is not just infrastructure, it's a complete transport ecosystem. Trains arrive directly below the terminal, allowing effortless transfers. The airport has also created hundreds of thousands of jobs and sparked rapid development around it, forming a thriving economic zone centered on aviation. The Three Gorges Dam transformed the Yangtze River into a source of clean energy and a major waterway. It is the world's largest hydroelectric project, stretching over 2,300 meters and standing 185 meters tall. Engineers used 28 million cubic meters of concrete and over 460,000 tons of steel. The dam created a 600-kilometer reservoir, flooding scenic gorges, but allowing ships to travel over 2,000 kilometers inland. To move boats past the dam, they built 5-tier locks and the world's largest ship lift, which raises 3,000-ton vessels 113 meters in 30 minutes. At its core are 32 turbines, each producing 700 megawatts. In 2020, the dam generated over 111 terawatt-hours, enough to power the United Kingdom for 4 months. It supplies clean energy to millions of homes and businesses. The dam also controls floods that once devastated the Yangtze Basin. Its reservoir can absorb huge surges, protecting downstream areas. Built over 17 years, the project displaced more than 1.3 million people. Cities were moved, temples relocated, and ancient sites preserved. At its peak, over 40,000 workers poured concrete non-stop for more than 3 years. The dam stands as a symbol of China's engineering strength and national ambition. While the Three Gorges Dam grabs attention, the Baihetan hydropower station represents the peak of hydroelectric engineering. With a capacity of 16,000 megawatts, it's the second largest hydro facility in the world, generating over 62 billion kilowatt-hours of electricity each year. Baihetan's power comes from 16 massive turbines, each producing 1,000 megawatts. These are not just larger versions of existing turbines, they are entirely new designs. Each turbine runner weighs 338 tons and is built to a precision of just 0.02 millimeters, finer than a human hair. This accuracy is vital, allowing the turbines to convert over 96% of water energy into electricity, even under extreme pressure, heat, and turbulence. The dam itself is a concrete arch standing 289 meters tall, about the height of a 100-story building, and holds back over 16 million tons of water pressure. It's built to withstand massive floods and earthquakes, using cutting-edge techniques learned from decades of dam building. Underground, a vast powerhouse stretches 217 kilometers, with a main cavern large enough to fit 13 Boeing 737 planes. The construction required new concrete formulas to reduce heat during curing and temperature control systems to prevent cracks. Transporting materials to the remote site was a huge challenge. Massive components had to be hauled down narrow mountain roads or flown in by helicopter. Every piece of concrete, steel, and welding was tested to perfection, because even a small error could be catastrophic. In southwest China, the Huajiang Canyon Bridge is redefining bridge engineering. Towering 2,051 feet above the canyon floor, nearly as tall as the Shanghai Tower, it dwarfs the Golden Gate and Eiffel Tower. Its main span stretches 4,658 feet, and the total length reaches over 9,400 feet. The bridge uses a stiffened steel truss suspension design, anchored by twin towers standing 859 and 672 feet tall. Its architecture even nods to the Art Deco elegance of San Francisco's bridges. Building at such heights posed extreme challenges: thin air, high winds, and dangerous conditions. Engineers installed 22,000 tons of steel trusses and cables in just 2 months, with parts prefabricated hundreds of miles away, demonstrating remarkable speed and precision. Costing about $283 million, the bridge was completed in 42 months. It cuts travel time across the canyon from nearly 1 hour to 1 minute, boosting local transport and economic development. Smart cable sensors track tension, temperature, and vibration in real time, ensuring the bridge's safety and longevity. Any issue triggers immediate alerts for maintenance. Globally, the bridge has amazed viewers. Many admire China's ability to make the impossible real. Some joke it looks like alien technology, while others praise its beauty and healing views. The Huajiang Canyon Bridge stands as a symbol of bold ambition and unmatched engineering. While most of China's megaprojects focus on the ground, the 500-meter aperture spherical telescope, FAST or Chinese Sky Eye, shows their ambition to explore space. It's the world's largest single-dish radio telescope, with a 500-meter wide dish covering the area of 30 football fields. Located in a natural depression in Gorges, FAST is extremely sensitive, 2.5 times more sensitive than the retired Arecibo Observatory. It can detect faint signals from up to 13.7 billion light-years away, helping scientists study exoplanets, dark matter, and even search for alien life. What sets FAST apart is its 4,450 movable panels, which adjust to track the sky without shifting the entire structure. This design, built with millimeter precision, ensures maximum sensitivity by minimizing errors. Building FAST was a technical challenge that respected the local environment. The karst landscape was ideal but required careful preservation. Its remote setting was chosen to avoid radio interference, and a special radio quiet zone protects it from outside signals. Since becoming operational, FAST has discovered many new pulsars and is helping researchers understand extreme physics. It also plays a role in the global search for extraterrestrial intelligence. Overall, FAST marks China's growing role in space science and its commitment to unlocking the secrets of the universe. If your country could build one of these projects tomorrow, which one would you choose and why? Let's get a global engineering wish list going in the comments. The Zhangjiajie Glass Bridge in Hunan, China, is the world's longest and highest glass-bottom pedestrian bridge. It spans 430 meters across the Zhangjiajie Grand Canyon and hangs 300 meters above the ground, offering the sensation of walking on air. Built with triple layers of 50mm thick hardened glass, the bridge is far from fragile. Engineers proved its strength by driving a 40-ton truck over it, causing only a 2-centimeter bend. Even when struck with sledgehammers, only the top layer cracked while the bottom layer stayed intact. At such heights, wind is a serious concern. The original glass handrail design was scrapped to avoid acting like sails. Instead, steel poles were used to let wind pass through, improving stability. Heavy glass balls weighing 500 kilograms and water tanks underneath help reduce vibrations, while bends in the railing prevent dangerous walking rhythms. Construction demanded extreme precision. Each glass panel was cut for clarity and installed by workers suspended hundreds of meters above the canyon. The psychological effect is just as intense as the engineering. Walking on transparent glass above a deep drop challenges the senses and tests nerves. More than a bridge, it's a thrill-seeking destination. It now hosts bungee jumps and extreme sports events, drawing adventurers from around the globe. The Huajiang Tunnel in Gansu Province is only 173 meters long, but it's known as the most difficult tunnel ever built. German engineers once called the project impossible and walked away. The challenge wasn't its size, but the treacherous ground it had to cross, waterlogged loess soil that acted like quicksand. Digging through this unstable, saturated earth was like tunneling through wet sand that kept collapsing. Heavy rain made it worse, raising the risk of cave-ins. Standard methods failed, and international experts declared the project hopeless. It earned the nickname Tofu Tunnel because the soil was as soft and unstable as tofu. Yet Chinese engineers persisted. The tunnel was vital for the Lanzhou-Wuwei Railway, which connects key regions in China. Without it, the entire rail line would be useless. To solve the problem, engineers created a step-by-step excavation process with vacuum dewatering to remove groundwater while keeping the tunnel from collapsing. Progress was painfully slow, just 2 to 3 meters a day, compared to 10 to 20 in normal conditions. The work was dangerous, with frequent floods of sand and water forcing emergency evacuations. Over 6 years, 1,200 workers labored day and night. Harsh winters added to the struggle, requiring teams to break ice so the soil wouldn't freeze and stop the work. Eventually, through innovation and persistence, the tunnel was completed. It introduced new techniques for stabilizing soil and building in extreme conditions. Though short in length, the Huajiang Tunnel became a symbol of human determination and Chinese engineering excellence. While the central route of the south to north water diversion project often gets the spotlight, the eastern route is just as remarkable. It stretches over 1,467 kilometers from Jiangsu province to Tianjin, using and upgrading ancient waterways like the Grand Canal. This route required more than just channel expansion. It redefined regional water flow. 23 massive pumping stations lift water by 65 meters, each capable of moving millions of cubic meters daily. Some pumps are among the largest in the world. The path runs through densely populated and industrial areas, demanding constant water quality monitoring. Advanced treatment facilities clean the water along the way, ensuring it remains safe for the hundreds of millions who rely on it. Engineers had to coordinate with existing roads, railways, and cities, even redesigning urban sections to fit the new infrastructure. The project also helps control floods by expanding channels to handle large volumes during heavy rain, protecting millions downstream. Environmental protection was a key focus. The road passes through wetlands important to wildlife, and special efforts were made to preserve and improve these ecosystems. Overall, the eastern route showcases China's advanced and holistic approach to water management. Yangshan Deepwater Port in Shanghai is a man-made island complex built to handle the world's largest container ships. Located 32 kilometers offshore in Hangzhou Bay, it was created because Shanghai's shallow river ports couldn't support vessels over 400 meters long or requiring 15-meter depths. The solution was to build a new deep-water port connected to the mainland by the Donghai Bridge, the world's longest sea bridge at over 32 kilometers. To construct the port, engineers moved over 100 million cubic meters of earth and rock, reshaping the landscape to create artificial islands and deepen the harbor. Equipped with advanced automated cranes, the port can unload a 20,000 container ship in under 24 hours, a task that once took weeks. Everything is run by smart systems that streamline the entire process. Now the world's busiest container port, Yangshan handles over 47 million standard containers a year, more than the ports of Los Angeles and Long Beach combined. It has transformed Shanghai into a global trade powerhouse and added billions to China's economy. The project also pioneered deep water construction techniques, storm protection systems, and sustainable port management practices that are now used worldwide. While the Kong-Zhuhai-Macao Bridge is an engineering wonder, its artificial islands are an even greater achievement. Built in the Pearl River estuary, each island spans about 100,000 square meters and connects the bridge to an underwater tunnel. These are not simple platforms, they are fully equipped mini-cities with roads, buildings, and utilities. Constructing them in a busy shipping lane was extremely difficult. Workers had to build amid passing cargo ships and shifting tides, placing thousands of steel piles into the seabed with millimeter precision to support the islands and the bridge above. The islands include systems to protect the marine environment, especially the Chinese white dolphins. Barriers reduce construction noise and vibration, and the island design helps improve local marine habitats. Engineers also developed new marine concrete that sets underwater and resists seawater corrosion, crucial for the bridge's 120-year lifespan. Drainage and flood protection systems were added to handle severe storms. Each island is built to withstand Category 16 typhoons and remain fully operational during extreme weather. The Beijing-Shanghai high-speed railway is more than a rail line. It's a transportation revolution. Stretching 1,318 kilometers and built in just 4 years. It connects China's political and economic centers at speeds of up to 350 kilometers per hour, completing the journey in 4 hours and 28 minutes. What makes it remarkable is not just the speed but the precision engineering behind it. The route crosses rivers, mountains, and crowded cities, each section requiring unique solutions, viaducts, tunnels, and bridges. Over 80% of the line runs on 244 bridges, totaling over 1,061 kilometers. Among them is the Danyang-Kunshan Grand Bridge, the world's longest at over 164 kilometers. The tracks were built to millimeter level tolerances to prevent vibrations at high speeds. Engineers developed new concrete formulas to handle harsh weather and constant pressure, pouring large, joint-free sections for stability. The electrical system runs on 25,000 volts of alternating current, with overhead wires precisely aligned to withstand aerodynamic forces from passing trains. Advanced signaling systems track train positions to within centimeters and safely manage over 400 trains daily. Since opening in 2011, the line has carried over 1.3 billion passengers. It's reshaped China's economy, turning Beijing and Shanghai into a single high-speed corridor where people can commute between cities faster than many daily drives. While others debated the future of transport, China built it. The Shanghai Maglev is the world's first commercial magnetic levitation railway. It uses magnets to lift the train 10 millimeters above the track, eliminating friction and allowing speeds up to 431 kilometers per hour, while making it the fastest passenger train in regular service. The train covers the 35-kilometer route from Shanghai Pudong Airport to the city in just 7 minutes and 20 seconds, a trip that takes over an hour by car. It reaches cruising speed in under 4 minutes, accelerating like a jet. Maglev trains float and move using electromagnetic forces between the train and coils in the guideway. There are no wheels or engines, lift and propulsion come from the same system. The guideway is built with millimeter-level precision and filled with thousands of coils that must be perfectly aligned. The train's aerodynamic design reduces drag and noise, making it more energy efficient than traditional high-speed rail. Built-in safety features ensure it stays stable even in strong winds. If power is lost, it lowers gently onto supports and stops safely. German and Chinese engineers had to invent new technologies to make maglev work commercially. Since launching over 2 decades ago, the Shanghai Maglev has carried millions safely and is now the foundation for China's next-generation maglev systems. Love seeing the future being built before our eyes? Hit that like button to support more jaw-dropping infrastructure deep dives. The most remarkable part of the Kong-Zhuhai-Macao Bridge is its 6.7-kilometer underwater tunnel, one of the most complex marine construction projects ever attempted. Unlike traditional tunnels bored through rock, this one was built from 33 massive concrete sections, each weighing 80,000 tons and measuring 180 meters long. These prefabricated segments were floated into place and lowered onto the seabed with millimeter precision. Despite strong currents, changing weather, and heavy ship traffic, engineers aligned each section within 5 centimeters, an achievement many experts once said was impossible. Preparing the seabed involved replacing soft silt with special foundation materials, requiring new underwater construction methods now used globally. Each tunnel section was pre-built in dry docks with roads, lighting, ventilation, and safety systems, then sealed and tested before placement. Special ships with dynamic positioning systems installed the segments, ensuring perfect alignment. On May 2, 2017, a tidal surge shifted segments 3 centimeters off. A self-developed hydraulic adjustment system corrected it within 15 minutes, saving the project. The tunnel includes emergency exits leading to artificial islands, fire suppression for hazardous cargo, and ventilation systems that maintain clean air, even during traffic jams. It handles up to 29,000 vehicles daily while exceeding typical road safety and air quality standards. China's Belt and Road Initiative is not a single project but a global network spanning Asia, Europe, and Africa. Involving over 140 countries and more than $1 trillion in funding, it is the largest infrastructure investment in history. The goal is to recreate the Silk Road for the modern era, linking continents through railways, ports, power grids, and communication networks that reshape global trade. Key efforts include the $62 billion China-Pakistan Economic Corridor, connecting Kashgar to Gwadar for faster oil access and regional growth. In Europe, Chinese investments have transformed ports like Piraeus in Greece into major hubs. In Africa, new railways connect landlocked nations to ports, like Kenya's Mombasa-Nairobi line, which cut travel time from 12 hours to 4 and boosted trade. Despite its ambition, the initiative faces criticism. Some countries fear unsustainable debt or doubt the local benefits of Chinese-led projects. Still, the Belt and Road Initiative reflects China's vision of a globally connected world. Its outcome, success or failure, will influence global trade and politics for decades. What we've seen is more than a list of impressive projects. It's a shift in how humanity builds the future. China hasn't just created faster trains or taller dams, it has redefined what's possible when a country treats infrastructure as a foundation for development. These projects go beyond China, changing global trade and proving that challenges like climate change and urban growth can be solved with enough effort and investment. Critics rightly point out concerns about debt, environmental impact, and local benefits. Still, China has shown that large-scale problems can be tackled through innovation, coordination, and willpower. As the world faces urgent issues, China's approach offers both a model and a challenge. Are other countries bold enough to build the future, or will they be left behind? Thanks for being with us. Leave a comment, like to show your support, and remember to hit that subscribe button for more exciting videos. See you next time.